How is my mic? Is it too hot? Is it about right? Um, I I'm streaming on a totally different computer than what I did last time, so nothing is set up. Oh, it just ramped up? Okay, is it better now? Okay, perfect. Alrighty. How are things how are things going with you? My coffee. Here it is. Yeah. Yeah, that's fair. Yeah, extremely weird times. Yep. Extremely weird for sure. Um, did my bitrate just drop? I'm on like Canadian residential internet, which is basically dial-up, so I can't tell if there was just a quality drop there. Do things seem mostly okay to you? Oh crap. Okay. Um, hmm. I don't know if that's an issue with the. Um, I'm streaming on my very old Mac, so maybe it just can't keep up with the bitrate, or it could also be internet. Let me try. Um, try reducing this here. Um, okay, all right. I reduced the bitrate a little bit. Do things look mostly clear otherwise? Oh boy, if it's really coming to that. Yeah, there's very little that actually needs to be compressed here. Like there's me, and then the screen will be mostly static. So you would think that this would be okay. Okay, perfect. All right. I have no idea if anyone's going to be joining. Without really thinking about it, I just said, hey, let's do this in the middle of the day, which is probably not ideal for everyone. Um, so I think this will probably just mostly be let's test the stream to make sure everything works. Um, can I record? Is everything. OBS has been crashing for me a fair bit, so I don't know if we'll have issues like that, but um, it might just be you and I figuring this out together, so hopefully this won't suck. Um, yeah, super weird times for sure, though. It's been I'm not in the Bay Area right now. I'm back up in Canada, um, but my partner's down in Oakland still, so that's been a stressor for sure. Yeah. Oh yeah, yeah. I can imagine. Um, Although I hear BART is nice and not super jam packed these days, which is maybe a silver lining. That's very Emeryville. I feel everyone in their loft slash industrial workspace having generators. Yeah. Okay. It might just be the two of us here, which is of course fine. I'm just going to make one quick change to the recording. Yeah, in fact, I remember years ago hearing about um, there being an East Bay mesh network that was, yeah, I think there were efforts at one point or another, but in the halcyon days of having, steady state reasonable infrastructure, Why would we need anything like that? Um, yeah, I can't remember who I was talking to who was really big in that effort in getting the mesh network set up, but yeah, as far as I know, unfortunately, it's not really happening these days. Well, what do you say? It's a few minutes past the hour. It might just be us, but I'm certainly groovy with that. Why don't we try and get started here? Oh boy. Yeah, I think I just saw another. Okay. All right, let's do it then. Okay, round 2. Let's HyperCard some more things. So let's make this happen. So I don't know if y'all saw the thread on Twitter where I was kind of describing what I thought we might build this time. Yeah, so I came across this video of like this YouTuber playing like this ancient Sumerian board game, and it looks like objectively a fun game to play. But then also it seemed like this would be a fun thing to build in an ancient computer system. But then of course just never had the time to actually, build it until all of a sudden found like we had lots of spare time for these sorts of things. So let's get started. I don't know how much we'll actually get done today. We might actually just spend the whole time getting the board set up and all that sort of stuff, and then start actually building the game a little bit later. But let's get started. So I'm going to make a new stack, which I'm going to call Ur. The game is actually called The Royal Game of Ur, so that's as good a name of a stack as any. So let's get started with building what the board looks like. So the board looks like this. So there are these, oh actually I should turn on a grid just to make things a little bit easier. Wait, are you serious? Did this actually exist at one point or another? If so, maybe we could just find a version of it and just play that instead. So what there is it's a tabletop game that kind of looks like this. So it's like backgammon, I think. Wow, seriously? Oh man, I should actually check this out then. So the board looks like this. It's actually not that big of a board, but it's got kind of an interesting shape to it. And then one, I think we just might fit on the screen, which is extremely, oops, which is nice and good. Oh. The emulator really complains when it thinks I'm trying to scroll, so periodically I send it into spasms of beeping. Out of curiosity, did you hear that beeping? I don't know if that was I don't know if audio from the emulator is getting piped through to OBS or not. Hello, Amsters Go. Nice to see you. Thanks for tuning in. Oh, stream is a bit locked up? Crap. I think I saw a blip down in the bit rate. Okay. Okay, well hopefully those lockups won't happen too much, and maybe I can see about making that a little bit better for the next stream. So the board looks like this, and then there are little pieces, that will move around the board in such a way, and we'll explain the rules of the game when we actually start implementing the business logic. I kind of want to give this a little bit of depth, something kind of like that. So it's kind of like we're looking down on the board from head on. I have to say that angle doesn't I'm not really in love with that angle, but we have something kind of like this. Yeah, I'm not wild about that because it kind of looks like the perspective here is it looks like it could be sticking out of the I guess it's that sort of ambiguous perspective thing there. It is beautiful. Yeah, it totally is. You know what? I'm going to suggest maybe a different kind of viewpoint for this one here. Maybe if we like have it rotate a little bit like that, the perspective will be a little bit clearer. Because I'm looking at this and it's like, looks like this is, it almost looks like a hollow box that I'm looking into, which I'm not a huge fan of. So I'm going to see if this works. If this looks reasonable, we can stick with it. Otherwise, we can just kind of go back to the other way of doing it. I'm going to propose that we have a board that's kind of at an oblique angle like this. And then what I'll do is, that might actually be too oblique of an angle. Let's try something like that. Maybe one notch more. That looks like a reasonable size, I think. So I'm going to just save a copy of that over there, just in case I need it again. So, oops. Oh. So, I think that's too small. Darn. I think I'm... Because we'll need icons to move like around the board, so I don't want to make it too small. Just so long as we're able to make it fit on the screen, we should be good. So I'm just going to see if I can make 8. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so this fits. So let me just draw the same board that we did before. Oh, I think this will look a little bit nicer. We'll have to do a little bit more calculation when we're moving pieces around the board, but I think this will be a little bit more satisfying as a result. So let's do that like so. If you didn't see see a photo of this board, it's actually really interesting because it's got these holes in the board, so it's not actually a rectangle. It's as a piece of furniture. It's kind of neat. Okay, so this is the top of the board. Now let's see how I actually like. Sorry, how I like the look of that. Okay, yeah, this seems... I think the depth is a little bit easier to visualize like so. Actually, Robin, you'll probably get a kick out of this. I actually got hired to write a HyperCard stack earlier this year in what is probably the most Portland thing I've ever heard. This guy in Portland who like watched the stream. I exchanged a couple emails with him, thinking that he was Hoverbird because they share the same name, and only later did I realize it was a different guy named Patrick. But it was this guy who had like followed the stream when I did it a couple years ago, and he said, "Oh yeah, so I run this escape room company, and we have an old Mac that we want to use as a puzzle, but we need a HyperCard stack built for it. Would you be willing to do it?" So I spent a couple hours hacking on that. Yeah, it was really nice. It was. I'm not sure when I'll ever be back in Portland to check it out, but it seems like if y'all are in Portland and you see an escape room game where there's a HyperCard puzzle, that was my work. Okay, great. So the board now looks like this. So what I'm going to do is, I should have done this the first time round. Can I? No, I can't do that. I'm just going to make a copy of one of the squares and move it over here, because we have to... I'll need to know how wide and how long each square is. So I'm just going to... Actually, that's probably good enough. So let's measure let's measure each one of these squares. So I'm going to do that with my old friend, the message box. So there's a command which I can run called the mouse lock, which gives me obviously the pixel coordinates of the my cursor. I'm going to do the mouse lock. So I'm going to write this down. My cursor is at 24 to 64. And then let's measure the width. Mouse lock. That's 72. So 72 minus 24, that's 48. So that's 48 pixels. And yeah, it's really nice. This is like one of the things I really like about having something so integrated like this. Interestingly, I've been doing a bunch of like front-end stuff for like my day job, my nominal day job at least. And obviously it's not to this level, but it's actually really satisfying to be able to sort of sketch out, like make sort of prototypes of the thing you're doing, the thing you're building as you're building it. As a backend or traditionally backend person, I had no real experience doing that. So it's super nice in HyperCard, and even in the front end world, it's also pretty nice. So from top to bottom, that's 264 to the mouse lock, 296. So 296 minus 264, 32. Okay. So it is 48 by 32. So let's write, I think the first thing that we actually want to write is a function that, like that if it takes a pixel coordinate, it tells me what square I want to be on. And so we'll do the straightforward thing where, we'll index, 0, 1, 2, and 0, 1, 2, 3, 4, 5, 6, 7. All this stuff should really be in the background. I'm drawing it on the card right now, but let's write the code in our background code. So let's write the function called screen to square. Sure. And it'll take an x and a y. Screen to square. One thing we do need is, because we'll be doing some math sort of relative from the sort of top of the board. All right, so I need to know sort of what our origin is. So that's the mouse lock. So 9616. I wonder whether we can always change that a little bit later on, but why don't we center that a little bit. So the mouse lock is 6416. So put 6416 into top left. All right, so this variable it's not just a string of numbers, it's also like, you can think of it as an array of 2 integers, because HyperTalk has both kinds of types. It has strings that can be coerced into ints, and then comma deliberated strings that can also be parsed as ints. It's very sophisticated. So what let's do is subtract item 1 of top left from x, subtract item 2 of top right from, top left. I don't know I did that, and I lost my chat window. Okay, hopefully that'll work. Man, the Twitch page is like very slow to load. Because I hope I'm still streaming. I'm disconnected altogether on my other computer. If you can hear me, can you say something in chat, just so I know I'm going? We're loading again. Okay. And it cleared the chat, so I guess I don't know. So, well, we'll see. Okay, perfect. Hello. All right, so as we were, so now what we're going to do is, because we know, we kind of want to normalize for the lengths of the, not to derail your talk, where does HyperTalk fit into the family tree of programming languages? That's a really good question. It is just weird, I think, sort of with the benefit of hindsight. I was reading a bunch of stuff just to kind of remind myself of like the syntax. And it seemed like they were really making a push for it being like an OO sort of language, which I think it's like not super clear. Oh, hello, Modern Surf. Thanks for coming in. I think it's not really object-oriented as we think of it today, but it's a little bit small talky, right? Like we have all these messages that you're sending to different entities. So like maybe something like small talk. It is weird though. There's really nothing that preceded it that I'm super aware of. Maybe our homework assignment can be to go figure that out. So where were we? Oh, we got to normalize, right? So dash dash is a comment, so normalize sizes. So we said put, oh shoot. So we said the height was 48. Y over 48 into J. I'll call it J. So I and J will be our board space, and then X and Y will be our screen space. I'll try and be consistent with that. So then put X over, I said 32 into I. Okay, so then once we have that, this would this would be the only thing we'd have to do if it was square, or if we were doing the original top-down thing. But what we want to do is, I should have thought this through. We want to shift the X value to the right. No, we want to shift the X value to the left, right? Because if my cursor is here, or let's say if my cursor is there, I want to think of that as the square 0, 0 and not square 0, 1, which it would be if we were just taking sort of the square overlays. So we want to subtract how much? So every time we go down a row, so the y-axis stays the same, which is great, right? So every time we go down, we want to shift it, I guess, by this much, right? So slock 96. So 96 minus 64 is 32. Okay, so that means if the cursor is here, we shift it by 0. If it's here, we shift it by 32. If it was here, we shift it by 2 times 32. Okay, so that's actually, I was thinking, like, do I have to remind myself how to write a rotation matrix? And it looks like we don't, which is great. So we are going to subtract 32 times J from I. And then at that point, what I think we can do is we can just return I and J, right? Oh, we want to round because these will be fractional values. So we'll do return I div 1. So that'll just floor it, and comma and J div 1. Okay. So if we said that the mouse lock 6416, let's try and call this screen to square of that. And we see 0, 0, fantastic. Let's try, oops, the mouse lock. So that should still be 0, 0. Uh-oh. Okay. So that's clearly wrong. I'm going to do something maybe a little bit different here. I'm going to add field here just to help me debug this a little bit. So this will be screen space, and then this will be board square. So what I'm going to do is, whenever we're moving the mouse cursor inside this button, we'll have it do we'll have it do this calculation and just update these fields just so I can kind of see what's going on here. Just to make this a little bit more like so. So instead of mouse up, which is the click handler, let's do on mouse within. So we'll do put item 1 of the mouse lock into X, put item 2 of the mouse lock into Y, and then we'll say put, I guess, the mouse lock into card field, what did I call it? Screen space. Sure. Okay. Let's see if that works. Okay, so that does the right thing. Extremely good. Oh, I see I'm dropping a little bit there. So then now what we will do is we'll say put screen to square of x, y into board square, put board square into card field board square. Okay, so as we move the cursor around, we'll see kind of what it's doing here. Okay. So, interesting. Well, let's take a look. So we normalize. Subtract item 1 top left from X over Y. Okay, so then this actually feels wrong. Put I minus, maybe I flipped those. No, okay. So that's strange, right? Like, you would think, oops. What have I done? Oh, hang on. No, 32 times J. So let's see. So at this point, so that's interesting. Should that have been 32 and 48? Yes, okay, so I flipped those. So it looks like the y-axis is doing the right thing, right? So you move down a row and it gets incremented. So now there's something goofy about, oh, I know what's going on. Certainly that should be, because the 32 pixel thing is in screen space, right? So the thing I want to do is say divide by, I want to divide by something. I want to divide by the width, which I guess is 48. Yeah, okay, that was the thing that was missing. Right, so right on the border between the rows, looks like we got the right thing. Okay, so just to make sure that it's working even down here, because you can imagine like errors getting worse and worse the farther down we go. But looks like that's doing the right thing. Okay, good, very good. Now let's, I guess we should write a function that does the opposite, right? Like, we'll need to place, I imagine there'll be buttons, buttons with icons that will have the pieces that we have to move around. So we'll need a way of saying, given that the piece should be at, 5,3 or 3,5, or whatever, where on the screen should be placed. So let's write, I guess, the opposite of the function here. So we'll do function square to screen, and then ij, because now it's in board space, and screen to, no, square to screen. All right, so I guess it's just going to be like this function in reverse, right? So what we'll do is I guess we need top left again. And then we'll multiply out, put j times 32 into x, put I times 48 into y. But now I need to do this shifting, right? So, I mean, is it just the opposite? I plus? This might be wrong. Well, we will see. So we'll do put x mod 1 concatenated with, or sorry, div. Y div 1, or return. Not thinking very clearly. This is what happens when you never leave the house, I guess. So now let's, oops, I'm going to have it print it in this one, which is called screen space. So let's do put square to screen. Oh, this is a little annoying. Item 1 of board square. Item 2 of board square. Maybe the arguments to that should be the tuple rather than two individual ones. Into, let's make that a little bit bigger. Into pixels, I don't know. And then put pixels into card field screen space. So let's see if that does anything. Okay, well, we forgot to add, we forgot to add the top left argument, right? Add item 1 of, item 1 of top left into x, add into 2. That's more grammatical, I don't know if it's HyperTalk, but item 2 of top left to y. All right, so 64, 16, 64, 64, 64. So it's kind of doing the right thing, I think. But I don't know if it's actually computing the right thing. Let's see. So I guess the thing we expect to see is kind of like the midpoint there. Oh, but we're not calculating the midpoint. The thing we would expect to see is that it's giving us the top left, right? So there, the top left should be 96, 144. The mouse lock is 192, 48. Okay. That's annoying. What did we say it actually was? Actually, let's do, I'll add one more here. Mouse lock. Just so we can actually see if we're off or not. Oh no. So then what I will do is put the mouse lock into card field mouse lock. Right, so we get 64, 16. I guess before we go any farther, I guess the thing we want to do is have it centered, right? Because that's kind of, when we move stuff around in HyperCard, generally I think the location of like a button is actually the center of it, which is nice because then it's sort of, you can scale the size of the button a little bit and you don't have to recompute everything quite so much. So I think the thing that we actually want this to be is the center of the square. So presumably what we want to do is add, oh, I flipped these again. That's probably what was wrong in the first place. 48, 32, add 32 over 2 to x, add 48 over 2 to y. I did these starting with, you know, x and y, and then but then j to I. Maybe this is why I'm getting confused. I don't know why I thought to do it in that way. Okay, so we expect the center to be kind of around there, but it says we have 80 and 40. Oh, it's because we need to take like that little bit into account too, which was 32. Yes, 32, I wrote that down. So then that should be, was it here? No. 48. So it now says the center is 96 and 40. Oh, so maybe I was right the first time. I don't know why I keep getting confused here. So while I'm doing this, what have you all been doing to stay safe with the quarantine? I know, like, Robin's in the Bay Area. Modern Surf, are you still in New York? I can't quite remember. Oh yeah, that's clearly not right. Okay, yeah. What am I doing wrong here? So the thing we want it to be is something kind of like there, maybe there. So it is saying it's too high, or we've moved too far to the right. No, we haven't moved far enough to the right, but we moved too far down. Let's see, so x is, oh wait, 48, 32. So it's now saying it's 88, 32, 88, 32. Oh yeah, okay, so that's actually exactly along like this edge here, and then we just want to add a little bit more to get over here, which is what I thought we were doing. 48, did we not say 32 plus 48? So now it drops us at 104.32, which is actually, that looks about right. Okay. Okay, very cool. So what time do we have here? It's okay, so we've been doing this for about half an hour. I know, at least for the West Coast people, this is probably your lunch break, something like that. I think last time we did like a small number of long streams. I might try and do like a shorter number of, or like a greater number of shorter streams. So why don't we actually try maybe moving a little bit of having a little thing move around the board. I think we'll probably spend a bunch of time making the art, which I think will actually be a lot of fun. But I'm just going to use a stock that's round. The little piece will be round. That's good enough for the time being. So we'll call this piece, or yeah, piece. Why not? So what I'll do is sorry, I'm not being clear on what I'm doing. I'm editing the mouse within script of that square. So why don't we say we've calculated like the center of the pixel for the board that we're hovering over. Why don't we say set the lock of card button piece to pixels? Ooh, Robin, when are you gonna? Is this something that's gonna be ready to demo at some point? It'd be cool. Wait, are you doing it in HyperCard, or are you doing a different sort of project? Oh, okay. Well, that's sort of working. Okay, so we've once again flipped my coordinates. So let's make sure we're actually returning. Oh, okay. No, that's too bad. Decidedly not HyperCard. Oh, that's a bummer. Maybe this is why I was so confused the first time around, because we're putting J should be Y. And then, oops, oh geez. So Y 32, 48 maybe? Okay, there we go. Okay, so when I was stomping that bug a few minutes ago, it turns out the problem was not what I thought it was. But okay, so what I'm doing is I'm just hovering over the squares, and every time we move the cursor, we're recomputing, what we think we're recomputing what square the mouse is hovering over, and then we're using that to come up with a new pixel location, which is the center of the board, and then we're moving the square there. All right, so that seems to do the right thing. Maybe just before we wrap up today, because we're kind of hitting sort of the end of what I had planned. Maybe what we should do is add a little bit of game logic into the mix, right? So here right now, even though there aren't squares here, because hopefully the perspective shows that there's a hole there on the physical board, we can still move the icon there, which is not what we want. So we should probably write a function that says you give it a board position, and it says, is this a valid position or not? And you could imagine when we start implementing rules for the game, you could say something like, so in the rules there are certain squares that you can't jump to if there's already someone there. So some squares are protected. Normally the way the game works, it's a little bit, I guess maybe like checkers, I don't know, where if you land on a square, you send like your opponent that you landed on back to the beginning, and they have to kind of go through it again. But there's certain squares where, like, if you land on that square and there's someone there, you just can't land there. So this function will probably end up being a little bit complicated when we start implementing, logic of the game. But for the time being, why don't we just say that you can't move the square, you can't move it off the board, and these these four squares are special cased to say, like, no, you can't be there because they don't actually exist. So let's go and write something like function valid square I j and valid square. So we'll say return true, which is not correct, but it will let us plumb through if valid square item one of board square. Item 2, board square. Yeah, I think it might be easier if we treated these as like vectors instead of 2 parameters. Maybe we'll refactor that at the end. Then, and if. So we'll oh wait, sorry. That's not the right thing, we'll do that. And then we'll set the button location only if it's a valid square. So, we shouldn't, oops, okay, well, syntax error, that's very, very cool, because I left off a parenthesis. And we now see it's basically doing the same thing it was doing before, because our little stub function over here is just always returning true. So let's make this a little bit smarter. We'll do if I is less than 0 or j is less than 0, then return false. And if. And we'll do the same thing but for the right side of the board. So if I 0, 1, 2, if it's greater than 2, there's like one indexing in HyperCard, so I was making sure that we're kind of combining 0 indexing and 1 indexing, which will be a problem at some point, I guarantee it. But right now, we can pretend it's not. So if I is greater than 2 or j is greater than 7, then return false. So what we should see right now is that we don't fall off the board like we used to. Well, indeed, we actually don't even do anything. That's interesting. So if I, oh, sorry, greater than 2, okay, great. Okay, so at this point, that's super cool. We can move our person down there, but we can't fall off the board. So the only thing left to do is special case these. So it's 0, 4, 0, 5, and then 2, 4, 2, 5? Yeah. Okay. This might be a little bit hairy. If I is 0 and j is 4, or I is 0 and j is 5, or actually, no. If I is 4 or I, no, sorry, that's j, because j is moving down. J is 5, then if I is 0 or I is 2, then return false, and if. Okay, so if it's 4 and 5, and it's, okay, so, oops. All right, so we still move there, and then it does not let us fall there, and then we snap to the other side. Okay, great, sounds good. What I'm going to do is maybe just to, so I have a little sketch of what the board looks like over here, so when I'm glancing over here, I'm reminding myself of what the board looks like. Some squares are a little bit special, so let me just mark which ones they are. So actually, before I go any farther, because I've been editing the card, let me just move this to the background. Because I'm going to draw stuff on top here just to help us. So here this is so if you land on certain, so basically the way the game works, to give you a little show of things, like it's two players. So if I'm on this side over here and my opponent's over here, I have pieces that move like this. They just kind of move. So you start here, you move up, you go down into this center square, sorry, the center column, where you can capture pieces if you land on them, and then you come back out and you follow up the other side. And you do that 7 times with 7 pieces, and then whoever does that first wins. But there are certain squares where if you land on the square, you get to go again. So those squares are, I think I called that S for a second time, and then 0, 1, 2, 3, and then here and here. So why don't we write two quick functions that check whether we've landed on a square where we can go again, and then there's another special case, and then maybe we'll do that and a little bit of refactoring, and then that should probably take us to the end of the hour, I think. So let us go back to the background. I'm kind of adding everything into the background here. Maybe that'll become a little bit unwieldy once we start having lots of different functionality. But for the moment, whatever. It's completely unclear to me how you would write like a large piece of software well in HyperCard. Unfortunately, it's just not really, kind of to the question earlier, it's like, what was the ancestry of HyperCard and HyperTalk in terms of programming, like programming language theory? Like there probably wasn't one. So let's do function go again square. I don't know what you would call that. And function, or sorry, and go again square. So let me, I can just move this over a little bit so we can see the squares. So it'll be 0, 0, 0, 2. If, oh, this needs arguments, doesn't it? So it needs I and j. If I is 0 and j is 0, then return true, and if, return false. This is a little unfortunate. We're going to have lots of duplication here, but so it goes. Sorry, I is 2 and j is 0. The other one is 1, 1, 2, 3, so 1, 3. And I think it was, yeah, it's the last square before you fall off, which will be 0, 1, 2, whoops, 0, 1, 2, 3, 4, 5, 6. Okay. And actually it's the same thing as before because it's on both sides. So why don't I just copy everything here? So if j is 6. Okay, let's add yet another one of these, which I'll call status, square status. So if we hover over one that is has a special status, it'll print something there. Okay, so if go again square, I need a better name than that. Let's move that up there, because this is all the mouse lock stuff happens at the top. Then, oh, let's do, how do I do this? Put into card field square status, I think we called that. Put S into card field square status. Okay, so that sort of worked. The thing I was expecting it to do was the empty string would just blank it out, but maybe it doesn't? That's actually kind of interesting. Did I implement this wrong? Maybe I did. Let's see. So our go, where's my go again square? If anyone has a suggestion for a better function name than that, please let me know, because it kind of sucks. Okay, no, so we return true if all those things hold. Otherwise we return false. Go again square 1, 1. Yeah? that makes sense. So it seems like it's doing the right thing. Square, did I spell that wrong? This is confusing. Else. Let's do some printf debugging here. Right, so this should, interesting. Oh, I'm a fool. No wonder. This should be go again status. All right, sorry about that. We'll do put into card field square status. And what we should see, go again square. This is what happens when you're trapped inside all day long. You're just not thinking super clearly. Okay, great. So that does the thing we want. Great. I'm just going to remove those there. And the only other thing that's special is 1, 1, 2, 3. So it's the one right before crossing this bridge here. If my opponent is on this square and I land on this square, this is the one where I can't land on it because it's protected. So normally if, I think I explained this already. If I was already, if my opponent is here and I land on this square, I do a capture, but it's protected here. So we'll special case 1, 3 to be the protected square. Function protected square and protected square. So this will be, takes I and j. This will be if I is 1 and j is 0, 1, 2, 3. Then return true, and if return false. So now let's see. We can do if protected square. I'm curious how we actually append something to a field. I don't remember how to do that. Add test to card field square status. I wonder if this works. Yeah, append? Do I have, I don't have, my HyperCard manual open here. So why don't we just say, as it set, let's do something a little bit hacky here. Set item 2 of to P, set item 1 of card field square status to S. Okay, so what I think what it'll do is it'll just append a comma. Oh, well, no, it won't understand what I mean. Put S into card field square status. I mean, the only reason why this matters is that the P square is also an S square, but it's not strictly important here, right? Like it would be nice to be able to show both, and I feel like I ought to know how to do this, but yeah. Okay. Well, good enough. I'll look up how to concatenate things in a card field and then maybe do that next time. I think the only other thing I want to do before we wrap up, we have 5 minutes before the top of the hour, so now is probably a good time to move on. I'm just going to do a little bit of refactoring. I think maybe the thing we should do is, maybe it's better if these are all like single parameters, because when you're calling into them, it seems like we always had to, extracted out in the caller. So it might be nicer if this was location, and then we'll do put item 1 of lock into X, put item 2 of lock into Y, and we'll do the same thing kind of down here. But this will be I and J. Actually, this will be the same for the, oh, maybe not. Is that the only ones we've written? Oh yeah, no. Alright, so we'll do that. And then that. And then here. Okay. So then here, what we will do is we'll say screen to square is just going to be the mouse lock. And then square to screen will just be board square. Board square. And then, yeah, I think I like this a little bit better. Board square. And it might even work once we've done that. Okay, let's see if it complains. Okay, great. So it doesn't complain. Is there anything else anything else we would like to do here before we call it? This is annoying. What I think I'm going to do is I'm going to, in the stack, so this is like a global function, I'm going to write, when I was writing the ray tracer, I don't know if you all saw this, but when I was at Apple, I was writing ray tracer and HyperCard on the Apple shuttle, thinking that this was a way that people at Apple would think I was cool. I did not succeed. But one of the things that I learned out of it is that it's nice to have in your stack script little helper functions to build. I called them vectors, of course, because it was a ray tracer. But I'll just call it the same thing here. So vec2 takes an x and a y. And so what it's going to do, x, y. And it's just going to return x concatenated with the comma. And then maybe I'll do function vec2 int xy. That'll just do the rounding. Vec2 int. So we'll do return vec2 of x mod 1 y mod, div. I think I did that once before too. Div 1 y div 1. So let's just make sure that works. Vec2 of 3 and 4 returns 3 and 4. Vec2 int of 3.14 and 2.71 should return us 3 and 2. Except it does not. What did I do wrong here? Oh, div 1. Great. Okay. So now once we have those, we can return vec2 int ij, and then vec2 int xy. And I think those are the only times that we do that. Okay. I guess you could also imagine stuff like adding like vector subtraction and stuff like that, which maybe we can do another time if we're bored. I think maybe this is kind of everything that I wanted to get done today. If people want to hang out and talk, that's cool. We can either just do that on twitter.com. So I don't know. I hope everyone's doing okay. It's been a weird couple of weeks for sure. So it's been nice to have social interaction on the internet. A friend of mine, Mark, some of you I think might know him. he like just suddenly turned on Twitch last week and was streaming a bunch of like weird VHS tapes that he collected. And so we just sat in sat in Twitch for a while and like dunked on these weird VHS tapes, and it felt like normal, which was nice. Thanks for tuning in, Robin, and thanks for everyone else for tuning in too. One thing that would be cool is, would you like let me know if this time works for people, or if they'd rather have it in the evening? I scheduled it in the day just because I wasn't really thinking, but there are probably people who have like stuff to do during the day, and maybe the evening works better for them. So if it works better for you, let me know, and then we can move it to the evening. Otherwise, yeah, we'll do this again in a couple days. I think we should add some art to make this look a little bit nicer. We'll start adding some business logic into the game. I think this will be a fun project to do. So thanks for tuning in, everybody. We'll talk to you in a couple days. Talk to you on the internet.